History of computing.
Computing in the past. From very early on in human history, we communicated and shared information through speech. It was only really later when we wanted to count things that we started to record information, such as counting possessions using tally sticks, cutting notches in the edge of the stick to correspond to an item. The Ashango bones are ancient bones found to have tally marks from as long ago as between 20,000 and 5,000 years ago.
Tally sticks lasted until medieval times and were actually implicated in the fire that destroyed the Houses of Parliament in 1834. It seems accountants were more successful at destroying the Houses of Parliament than Guy Fawkes. Counting schemes. There are many different counting schemes, ranging from Aztec numbers, Babylonian numbers, and Roman numerals. Zero was introduced when Arabic digits made calculating easy and made use of simple rules. Arithmetic. Arithmetic is based on the representations of numbers. Abacus. The abacus was the first mechanical counting aid, still widely used to this day, and can represent notation depending on its use. Mechanical devices. Pascal's adding machine allowed you to dial numbers to add the numbers, whereas the Brunsviga calculator was a machine that on one turn would add, multiple turns would multiply. Later mechanical calculators. These mechanical calculators developed until 1960. Qutub developed this small handheld barrel in 1948. Alpina sold in 1961 was the last new mechanical calculator.
Charles Babbage. Charles Babbage was a professor of maths at Cambridge and developed many ideas for automatic computation. He built a difference engine that would calculate and print mathematical tables, but it was barely finished. Analytical engine. Babbage went on to develop the analytical engine, which was mechanical but programmed by punch card. The prototype was finally demonstrated by the Science Museum in 1991.
Ada Lovelace. Lord Byron's daughter wrote notes on the analytical engine and translated them into Italian. She also wrote a program for the engine, now considered the world's first computer program. Turing machine. Alan Turing used mathematical abstraction to come up with the idea for the Turing machine. This abstract machine could solve a difficult mathematical problem to do with whether or not every problem has a definite solution. He then disappeared during the Second World War to work on code breaking at Bletchley Park.
Colossus. Moving on to Bletchley, other colleagues of Turing developed various mechanical aids for breaking codes, resulting in the machine known as Colossus. It was so secret that it was unknown until about 1975. That's 30 years secretly stashed away in Bletchley. The development of Colossus explains why the UK had an early lead in electronic computing construction.
American developments. ENIAC. Created to calculate ballistic tables. This wasn't finished by the end of the war, and was rewired to perform a different set of calculations. Punch card machines, data manipulation. Herman Hollerith invented a machine to count holes in punch cards. Used in the US 1890 census, where previously the 1880 census took 7 years to count. Business use. Over the next 70 years, machines were developed to do basic accounting functions, sorting cards into different hoppers, adding columns, etc. IBM built a punched card, 80 columns with 12 rows for holes. Think of how many symbols could be represented this way.
Relay machines. US academics developed a relay-based machine like the SSEC, built by IBM. British developments. Manchester University had a demonstration of a fully electronic computer in 1948 called the Baby. The Manchester Mark I followed then Mark II, commercialised by Ferranti. In Cambridge, the EDSAC used storage lines that worked by circulating sound waves in tanks from mercury. Lions corner houses were the Starbucks of that day on many street corners. Thousands of clerks processed the orders, and Leo was deployed as the world's first business computer.
Early computing, future predictions. The computer salesman for the Ferranti said, "We have a computer here in Cambridge, there's one at Manchester and one at the NPL. I suppose there ought to be one in Scotland, but that's about all." There have been many predictions about how many computers would be needed. Later, many people doubted the need for a computer on the desk. Others, Bill Gates included, didn't think the internet was important, so best to take all our predictions with a pinch of salt. Input and output. Punch card readers were the most common input device. A card reader would read 2,000 cards a minute. Line printers were the major output device, printing 600 lines per minute. Disk drives were big and heavy and required carefully controlled environments. Magnetic tape drives were used for volume storage. Desktop computers, such as Apple II in 1977, Commodore PET, Sinclair ZX80 and ZX81, BBC Micro, and IBM PC in 1981.
Heriot-Watt University, School of Mathematical and Computer Sciences.